So I'd like to welcome you to this webinar today. We are presenting an introductory webinar on hands-on equations fractions, and this is Dr. Henry Borenson, the inventor of the program. Occasionally, but very rarely, we have technical issues. If they do, just stay put. Usually they are resolved very quickly. And at the end of the webinar, we will be raffling an individual set of hands-on equations fractions. So the first program that I developed 30 years ago was hands-on equations and has been used quite widely in the United States, especially with gifted students, but also in the general population. And that led to hands-on equations fractions because we received requests to solve equations involving fractions. So first, I would like to spend a little bit of time just on hands-on equations to make sure we understand some of the basics. The purpose of hands-on equations is to demystify the teaching of algebraic concepts so that everything makes sense. We don't have students knocking their heads against the wall trying to figure out what to do, but the light goes on. So in hands-on equations, each student has a flat balance scale and a set of game pieces, blue pawns and number cubes. And the teacher has a demonstration scale in front of the room. It has no moving parts, and it has larger game pieces in order to represent the equations. And in hands-on equations, we have a blue pawn, and we need to find out its value. So what I want to do is just illustrate one equation from hands-on equations, and I'm going to do that with lesson number 3. And I maintain that if you're working with gifted students, your gifted second graders can learn to solve this type of equation in just 3 lessons. Otherwise, all of your students in the 4th or 5th grade can easily do that. So what I'd like to do is illustrate that on the interactive application. So here's the equation, 4x plus 2 equals 3x plus 9. I have already set up one side of the equation. The x's are represented by blue pawns. As you can see, I have 4 x's, 4 blue pawns here, and a cube with the number 2. On the right, I need 3 x's plus 9, so I'm going to place 3 blue pawns up here. Okay, that pawn disappeared. Let me put it back on. And a 9 cube. Okay, so this is what we call the original physical setup of this problem. Now we can solve this equation by doing legal moves. That is, we remove the same value from both sides of the equation. That's called a legal move. The technical name for that is the subtraction property of equality. You don't need to give that name to your students, but that's its name. I can do another legal move by removing 2 more blue pawns from each side. And now, since this side has a weight of 9, this side must have a weight of 9. This has a weight of 2, so the pawn must be 7. In order to do the check, we reset the original problem one more time. Let's see. Okay. Usually I can do that in one step, but okay. So we set up the original problem one more time, and then we see if both sides have the same value. So if x is 7, we have 7, 14, 7, 14, 21, 28, 30, 7, 14, 21, and 9 is 30. So this then is the basic idea that is used in hands-on equations. So on the teacher's demonstration scale, the teacher uses both hands to simultaneously remove a pawn from each side, and we encourage the students to do the same, to to use both hands when they remove a pawn from each side. Okay, 1 second. Okay. And on the student scale, this is the equation 4x plus 2 equals 3x plus 9. Notice that the number cubes are facing upward, facing the ceiling, so that as you, the teacher, walks around the room, you can quickly see if the students have the correct setup. And this is how the students perform the legal move. They bring down the pawns down. And then in order to check, they clear the board. I didn't do that in the example I just showed you, but to do the check, you clear the board and you set it up one more time in order to do the check. So in hands-on equations, we set up the equation using pawns and cubes. We solve for the unknown using legal moves. We clear the scale and reset the scale to conduct the check. So as we move into hands-on equations fractions, we're going to be using similar strategy. And as I mentioned a minute ago, when we remove the same number of pawns from each side, that's called a legal movement, but it's also the subtraction property of equality. Okay, so instead of saying to the students, whatever you do to one side, you do to the other, in which case students can remove a 2 constant from one side and a coefficient from the other, we say we can remove the same value from each side. We can remove the same number of blue pawns from each side. And there's research that shows that hand gestures can make a dramatic difference in student learning. So that was 7 minutes of a very brief introduction to hands-on equations, and now we're ready to move to hands-on equations fractions. And that came about as a result of teacher requests to solve fractional linear equations. So I'll be focusing today on some of the lessons from level 1. Each student has a flat laminated scale. They have a set of fraction blocks, and they have a set of number cubes. And the program may be used with gifted students as early as the 2nd grade and with average students in the 5th grade through the middle school and higher. So before we can work with the equations, we need to learn the relationship among the various fraction blocks that we have. So let's do that. If we consider the yellow block as the whole, as you could see, you have 2 red blocks that equal the yellow block. So what we do generally in the classroom is we ask the students to, how many of the red blocks make up the yellow blocks? And they either put it on top of the yellow block or next to it, and they see that 2 of them. So since 2 of the red blocks are the same size as a yellow block, each red block is called a half. And we write it this way. We say if Y, the yellow block, has a value of 1, then R, the red block, has a value of 1/2. Okay? So that's what this notation means. And similarly, the students find that 3 of the blue blocks are equal to the yellow block. And since these 3 blue blocks are each of the same size, each one is 1/3 of the yellow block. So we have if Y equals 1, B for the blue block is 1/3. And similarly, as you could see, there are 6 green blocks that make up the yellow block. So if Y equals 1, G is equal to 1/6. So let's review. Okay, using your text chat panel, please. If Y equals 1, please tell me how much is the red block. I know some of these answers are obvious, but you'd be doing something similar with your kids. Okay, text chat your answer. How much is the red block? So the red block is 1/2. How about the blue block? Please text chat the blue block. B equals. Okay, and how about G? How much is G? What is the G? The green block. The green block will be 1/6, okay? Now, I have to tell you, even working with 1st graders, it takes a matter of minutes for them to very quickly associate that if the yellow block is 1 or the whole, that the red is 1/2, the blue is 1/3, and green is 6. I have never had a child have difficulty remembering those. Okay, so they learn that very quickly. Okay, now in our program, we need to know what we mean by a unit fraction. A unit fraction, 1 over n, like 1/2, 1/3, 1/6, is one part when the whole is partitioned into n equal parts. So for example, the red block is a unit block, the blue block is a unit block, and the green block is a unit block, unit fraction. So a unit fraction has a 1 in the numerator. So it turns out that in hands-on equations fractions, we will always solve first for the unit fraction, and then we'll use that information to figure out what the yellow block is. But I just got ahead of myself, so let's wait a little bit for that. So if y is equal to 1, would you name each fraction? Please text chat your response. If the yellow block is 1, what is the name of this fraction displayed by the green blocks? May I have your answer, please? Okay. Okay, we have, we're getting the responses of 5, 6. How about the blocks in red? What fraction do those blocks indicate? The blocks in red, please. Okay, good. 1.5 or 3/2. And how about the blocks in blue? The blocks in blue would be 2/3. Okay, fine. So before you go further with solving equations, the students need to be able to identify fractional blocks such as you see here. Now, supposing that the yellow block is not 1, but supposing that the yellow block is an unknown, namely y, what would the red block now be? Would you text chat your response? If the yellow block is y, what is r? It's no longer 1/2. What is it? It's 1/2 of y. It's 1/2 of y. And how about the blue block? The blue block would be what? What would the blue block be in terms of y? The blue block would be 1/3 of y, and the green block would be 1/6 of y. Okay, so this, hopefully this doesn't look very intimidating, or should not look intimidating. All this says is that the red block is 1/2 the value of the yellow block. The blue block is 1/3 of the yellow block, and the green is 1/6 of the yellow block. So, so these are the answers that I think. Let's see. Did I ask you this? Oh, that's interesting. I forgot to ask you the question. I'm showing you the answer. Okay, so this fraction is 5/6 of y, this is 3/2 of y, and this is 2/3 of y. Would you let me know if you agree with this? If the yellow block is y, do you agree with these names? Okay, am I getting yes? 2/3 of y, 3/2 of y, 5/6 of y. Okay, fine. Now, it turns out that terminology is extremely helpful in learning anything, and also in learning mathematics. The more precise teachers and students can be with language, the better the chances that students learn what you want them to learn. So we use the language of copies. The numerator of a fraction specifies the number of copies of the given unit fraction. For example, 5/6 of y are 5 copies of 1/6 of y. So I'd like to pause here for 20, 30 seconds. I want you to read that, digest that, to see if that makes sense. 5/6 of y are 5 copies of 1/6 of y. And here you see 5/6 of y. And as you can see, there are 5 copies of 1/6 of y. So is everybody comfortable with that notation? Please say okay if you're comfortable with this notation. 5/6 of y are 5 copies of a sixth of y. Okay, good. Okay, so with that introduction, we're ready for lesson number 1. Now, you will note that even though this is lesson number 1, if you give this problem to your 4th or 5th graders, average 4th or 5th graders, chances are that a good many of them will not be able to answer the question. Now, let me just check with you. Does that seem reasonable, that chances are your average 4th or 5th graders will not be able to answer the question? If that seems reasonable, would you text chat yes, please? Or am I mistaken? Okay, and yet we have a very nice approach whereby the students can learn to solve this equation. And if you're working with gifted students, they can do this as early as the 2nd grade. So what I'd like to do now is show you how the students would do this on their scale. Okay, so let me see if I can get this showing here. Okay, so the equation says 2/3 of y is 16. Who can remind me which block is 1/3 of y? Would you text chat your response? Which block is 1/3 of y? It's a blue. So here we have 1/3 of y, but the problem doesn't say 1/3 of y, it says 2/3 of y. So I need 2 copies of 1/3 of y, and we're told that the value is 16. So here I have a 10, and here I have a 6. Okay, now, if those 2 blue blocks together are 16, please text chat the value of each blue block. Both of them together are 16. How much is each blue block? Please write B equals. Okay, write B equals, and I'm getting B equals 8. Okay, so I'm going to place an 8 over here. Now, if the blue block is 8, I need your help. What's the yellow block going to be? I know that the unit fraction, the blue block is 8. What is the yellow block? So to answer that question, you need to figure out how many times the blue block goes into the yellow block. So either the students know that, or they place the blocks on it, and they see that 3 of them will go on it, and therefore the yellow block will be 24. Now, to do the check, we go back to the original physical setup. In this case, it's already set up. So let's do the check. If the blue block is 8, 8 and 8 is 16, 10 and 6 is 16, so both sides have the value of 16. So that's the idea behind lesson number 1. Notice we first solved for the unit fraction, and then we solved for y, okay? So that shows you how the problem is done on the student scale. For the purposes of this webinar, I'm going to use the Smartboard application. So this problem we already did. 2/3 of y is 16. So now I would like to go to the next problem. I'd like to go to the next problem, so let's see. Okay, let's do this one. So I'm going to need your help. I need your help. I have to set up 3/2 of y. Would you please text chat, what do you want me to set up on the scale to represent 3/2 of y? And notice the terminology that I use, 3/2 of y. You can also say 3/2 y. I prefer to say 3/2 of y. So how shall I set that up? Okay, so I'm getting 3 red. So the idea is that the red block is 1/2 of y. So this is now 2/2 of y. This is now 3/2 of y. Plus 4 is 19. Now, each lesson of hands-on equations fractions introduces a new concept. Notice that this lesson, lesson 2, is more involved because now we have constants on both sides of the equation. So you saw the preview with hands-on equations, so we're now ready to use a legal move. Would someone suggest what legal move we can perform, please? What's the legal move that we can perform? I can simplify, I can work with the cubes. In particular, what can I do to simplify the cubes? I can subtract a 4 value from both sides. So we could do a split, but we don't really need to do that. Okay, we could simply subtract a 4 value from here. And I can subtract a 4 value from here. And make that a 5. Okay, so 19 take away 4 is 15. And now I have 3 red blocks are 15. Please write down for me the value of the red block. R equals, okay, what does R equal, please? R is equal to 5. Okay, so let me write here 5. Okay, let me get the white. Okay, so if R is 5, what is the yellow block? Now, notice that if R is 5, these pieces down here enable you to quickly determine the yellow block. So as you can see, 2 of the red blocks equal the yellow block, so Y is equal to 10. Okay. Okay, now to do the check, we're going to set up the original problem one more time. So we have 3/2 of y plus 4. Okay, I don't know what's happening there. Plus 4 is equal to 19. Okay. Okay, so let's do the check. So to do the check, I need to evaluate both sides. So if R equals 5, I'm going to have here 5, 10, 15, and 4 is 19. And on this side, 10 and 9 is also 19. Okay, so for the check, I'm going to have 19 equals 19. Okay, that's in blue, but that's going to be the check. Okay, so in lesson number 2, the students learned that they can do a legal move with the cubes to simplify the equation. So before we go further, do I have a question, please? How many of you think we're doing fine? Say, just text chat fine to tell me you're doing fine. You're following along? Okay. Okay, the rest of you, please feel free to text chat. I know we have quite a number of others here. Okay, good. So let me now go on to lesson number 3. Now, notice how in lesson number 3, the equation becomes more complex because now we have several terms involving the yellow block. So first of all, it says 2y. So let me do that. Okay, so we have 2y, 1y, 2y. Now, notice that this problem involves subtraction, not addition. I need to take away 3/2 of y. Remember that the halves are the red blocks, but I don't see any red blocks here, so I need a suggestion. Thank you, Claudette. I need a suggestion. How do I remove 3/2 of y when I don't have any halves of y shown? I just have 2 yellow blocks. Okay, do we have a suggestion? Replace each yellow block with 2 reds. Okay, so we could do it. We can make an exchange. Okay, I'm going to take this yellow block from here, and I'm going to replace it by 2 yellow blocks. Okay, I'm going to get rid of that guy. And I could do the same thing here. Okay, so notice we still have 2 yellow blocks, but now we've expressed it in terms of half of y. And now we're in a position to take away 3/2 of y. So let's do that. 1/2 of y, 2/2 of y, 3/2 of y. Now we need to add a 3 cubed. And on the other side, we have a 10 and a 5. So now we could do a legal move. Let's take away 3 value from the constants on both sides. So this 3 goes out. And the 15 becomes a 12. So notice at this point that that r is equal to 12. So let me write it over here. Okay, so if the red block is 12, you already know that the yellow block is 24. So now to do the check, we set up the original problem one more time. So the end result of 2 yellow minus 3/2 of yellow of y would be a red, and then I have a plus 3 here. And on the other side, I have a 15. Okay, let's do the check. If r equals to 12, 12 and 3 is 15, and this side is 15. So for the check, we do have 15 is equal to 15. Okay, question or comments, please? Okay, that's lesson 3. Okay, great. Now, the way the program works, there are 2 teaching examples that you, the teacher, do with your students. In other words, you coach them through it. The students come up and they do it with the document camera or on the interactive whiteboard, and then they have a worksheet of 8 problems, 4 on the new lesson and 4 review problems. So the whole program has 12 lessons and some enrichment exercises. So right now, let's go to lesson 4. Let's do this one. Now notice, who notices what's new in lesson number 4? So what's new is that now you have the unknown y on or fractional parts of y on both sides of the equation. So notice in just 4 lessons, the students are doing equations like this, which, on the surface can look intimidating. So let's start. I'm going to start by setting up 2 yellow blocks. Okay, I need your help. 1/3 of y. Tell me what this, or just give me the whole setup. Okay, 1/3 of y is a blue. And here you have the 4. And on the right, we have the yellow block and the 20. Good. Okay, who would like to suggest a legal move? We can always remove the same value from both sides of the equation, a legal move. We can remove a yellow block from each side. So notice when they start to work algebraically, in the optional lesson, they start to do this algebraically. They now subtract a y from each side. So this y will disappear, and 2y will become 1y. Okay, but that's later on. So let's remove a y from each side. And now let's remove a 4 value from here, and a 4 value from here. And then this becomes a 16. Now, we have a little problem here. We have blocks of 2 colors, and that's not helpful because we can't solve for either of them. May I have a suggestion for how to make these blocks be blocks of 1 color? How can we get it? What would be a common denominator block? We could trade for blue. Okay, so we can exchange the yellow block for 3 blue blocks. You don't have to set them up that way. You can set up any way you want. So now notice we have 4 blue blocks are 16. So please, what is the value of each blue block? Tell me the value of each blue block, please. 4. Now notice that beginning of lesson 4, we no longer write b equals, we write 1/3 of y equals. Okay, so 1/3 of y is equal to 4. And if 1/3 of y is 4, y will be equal to 12. How do you know that? Well, 4, 8, 12, or later on the students might see that you could do something here with the 3 and 4. 1/3 of y is 4 means y is 12. Okay, let's do the check. So in order to do the check, I need to set up the original problem one more time. So let's see how I can do that. Okay, excuse me. There's a way to get rid of these at one time, but anyway. Okay, so here we go. So we have 2 yellow blocks plus a blue block plus a 4 is equal to the yellow block plus 20. Now, if both sides don't have the same value, the suggestion we have is do the check one more time. If the check still doesn't work, then the student has to go back and redo the problem from scratch. So how shall we do the check? Well, the simplest way is probably this way. We know that the value of the yellow block is 12, so 12 and 12 is 24. We know that the blue block is 4. So we have 24, 28, 32. So let me write 32 over here. And let's see what the right side is. 10 and 10 is 20 and 12 is 32. Okay, so there it is. Okay, so that's lesson 4. And in lesson 4, the students are now working in terms of subtracting constants from both sides and the unknown or parts of the unknown from both sides. So before I continue, let me get some feedback from you. What do you think about this approach to teaching your students fractional? What do you think about what we're doing? Do you like it? Your thoughts, please, your comments. Okay, I love it. Like how it teaches the concepts, an awesome tool. Okay. It's a great next step for the students who already love the algebraic equations, right? So if they already had hands-on equations, level 1, they'll move into this very, very smoothly. We've also used this program with students that didn't have hands-on equations, and they were able to adjust well, but certainly having hands-on equations first is highly desirable. Okay, now I see that our time is moving along here. So I have two videos that I can share with you. This video is a first grader, and she's doing an equation from lesson 3. You won't be able to hear her. You'll be able to see what she does, and I'll be able to tell you what she's saying. How many of you are interested in seeing this video by a first grader? Okay, so let's do that. So I'm going to verbalize what's happening. I'd like you to help me with this problem. Please place a y over here. The problem says to add a third of y. We also need a +1. Wonderful. All that is equal to 9. So far, we have this set up for the problem. Do you see any legal moves we can perform? She says, yeah. Tell me what you're doing. I'm taking a 1. Taking a 1 from one side, changing a 9 to an 8. Now, the problem we have now, it's good that we have the 8 by itself. We have two colors here. Before you do it, tell me what you're going to do. So she said, I'm going to take out the yellow and exchange it for 3/3. She didn't say 3 blue, she said 3/3. Now, we have 4 blue blocks equal 8. How much is each blue block? 2. Do you know another name for the blue block? A third of y. Please write 1/3 of y. Equals to 2. We just said the blue block is 2. Now we need to solve for y, so the question is this. If the blue block is 2, what would the yellow block be? How do you know it's 6? She says 6. Because she says 3 of the... Okay, first she said 3 of the thirds are the y, and then she said 3 of the blue fit here, and each one is 2, so 6. So y equals 6. However, you're doing very nice. However, now we need to do the check. So please clear the board and set up the original problem one more time. Y plus a third of y plus 1. Okay, let's see if both sides have the same value. Y is 6. She says 8, 9, equals 9. Hey, 7. Pretty good. Okay, so normally 7 is in the 2nd grade. I'm not sure why she's in 1st grade, but anyway. Okay, very good. Okay, great. So at this point, we'll send you, when we send the recording of the webinar, we'll be happy to send you that video so you could watch it. We also have another video of a 5th grader solving a lesson 4 that we just did, but we won't show you that right now. That's available on our Facebook page, Hands-On Equations Facebook page. So at this point, what I'd like to do is begin wrapping up the the webinar. First of all, how many of you are happy that you attended here today? Okay. Okay. Let me see if I can give Claudette the, let me see if I can unmute you. Okay, and let's see if I can hear from you. Would you try speaking, Claudette?
Okay.
What did you think about what you saw today?
I really liked it. I liked how it actually brings a visual component to the concepts, and I like how you do a gradual release from the colors and then start using, like, you know, 1/3 Y and all that stuff. So it really moves them into the algebraic expressions and terminology.
Okay, wonderful, very good. Okay, great. No, we recommend this program after level 1. They don't need to wait level 3. After level 1, you may move on to hands-on equations, fractions. Okay, so you have available class sets of hands-on equations, which are just the linear equations. And you have the individual set of hands-on equations, fractions. We have class sets, so each student will have a set of number cubes and fraction blocks in a white bowl. And then we have the application that I've been using, hands-on equations, fractions for the smart board and for the interactive whiteboard. Those are available. And we have workshops, full-day workshops. This particular workshop we've done more than 2,500 times. More than 50,000 teachers have gone through the Making Algebra Child's Play workshop. And we also have a Demystifying Verbal Problems workshop, hands-on equations, fractions workshop. So thank you for attending this. Don't go away. We're going to do the raffle. Thank you for your interest in hands-on equations, fractions, and Making Algebra Child's Play. So now we're going to be raffling the individual set of hands-on equations, fractions. It has a set of fraction blocks, a laminated scale. It has the 2 manuals, level 1. Level 2 works with green cubes, negative constants. It has a set of worksheets and an answer key. So what we're going to do is this. There were 20 people registered for the webinar. I need you to enter a number from 1 to 20, and the individual that gets the number or is closest to it will win this set. Okay, so would you all please enter? Okay, anybody else? That's it? Okay, viewer 4, what is your name? Let's see, you have 2 numbers there. There are 2 numbers there. Do we have 2 viewers 4? How could that be? We have 2 viewers 4. I don't understand what that means. Has everybody entered a number? One is Kathleen. Okay. Okay, so let's see who's the winner. Here we go. And the winner is okay, come on, reveal the winner. The winning number is 5, and Kathleen is only 4 away. I think she's the closest because Andrea is 6 away. So Kathleen, you are the winner. Congratulations on winning the hands-on equations, fractions learning system. So be in touch with the office, although I expect that they will be in touch with you. So write to info@borenson.com. So everybody, ladies and gentlemen, thank you so much. If you have any questions, please be in touch with us, and we'll be happy to send you a link to the recording of this webinar in case you want to share it with your colleagues. So thank you again for joining us. Any last questions before we log off? Okay, Claudette, thank you so much for your participation. I'm so happy you were with us. Okay, closing down.